All right, guys, then we got rational functions. Rational functions, anytime you see the word rational in any kind of algebra class or math class, it means fraction. All right, a rational function is a function of this form, where it has a polynomial numerator and a polynomial denominator, meaning there's going to be an x in your denominator somewhere. There's probably an x in your numerator too, but definitely an x in your denominator. The parent function is this right here. It's f of x equals 1 over x. There's actually a sign in our classroom above the whiteboard that has a picture of this graph on it. It has a picture of this graph. I punched it in a calculator just so you can see. This is the calculator graph of it. This is one I found online somewhere. A couple things about the graph. First of all, it has asymptotes. The x-axis is an asymptote, and the y-axis is an asymptote, which means the graph gets closer and closer to them, but never, ever touches them. All right, so this one says tell what the domain and range is. Domain remembers how far your graph goes left to right. It's going from negative infinity until it gets to the x-axis. Then it stops and jumps over, and then goes from 0 to positive infinity. So it's going left and right forever except the 0. And the range does the same thing, okay? It's going down forever, and it comes up and gets closer and closer to the x-axis, but doesn't touch it. Then jumps over the x-axis and goes from there to infinity. That's why I put the parentheses with the 0, because it doesn't actually touch the x-axis or y-axis, so you can't include the 0. All right, so forever up and down, forever left and right, except that it jumps to 0. All right, this one says graph the rational function using transformation. Okay, here's what I know usually. Usually my asymptotes are at the y-axis and x-axis. Because there's a -3 down here, that's inside the denominator, which means it's going to shift your graph 3 to the right. So that asymptote that usually goes up and down on the y-axis is now going to go right here, right through 3 on the x-axis. Now the 2 on the top, you could rewrite that like this. The 2 on the top is really like having a 2 in the front, which means it's a vertical stretch by 2. And to be honest with you, it's hard to see that on the graph that's been stretched by 2. But the graph is going to do this general shape right here. And the only difference is it's been shifted 3 to the right because of the x minus 3. So those gestures we learned a long time ago, they never go away. No matter what you're graphing, you can use them. All right, finding asymptotes of rational functions. To find the asymptotes, I'm going to give you gestures for these tomorrow too, but this is a good slide, to be honest, just to have a picture of or notes on. So I need to write them down, take a pic, do something. The vertical asymptotes are whatever makes the denominator 0. So whatever makes the denominator 0 would be your vertical asymptotes of any of these graphs. Horizontal asymptotes, a little bit different. I want to say one thing about the horizontal asymptote before I tell you how to find it. The horizontal asymptote is what the ends of the graph are doing, okay? It's like end behavior. What are the ends of the graph doing? What are they getting closer and closer to on the left end and the right end of your graph? That's what horizontal asymptotes tell you. Okay, so it says n and m here. N is the degree of the top of the numerator. The m is the degree of the denominator or the bottom. So if your degree on the top or the numerator is less than the degree of the bottom, the asymptote is y equals 0, which, by the way, that's the x-axis. Okay, that's the x-axis. If the degrees are the same, if your exponents are the same on the top and the bottom of the numerator denominator of a fraction, you do leading coefficient over leading coefficient. Your horizontal asymptote is y equals, in this case, a over b. Right, and the last case is, what if your numerator degree is bigger than your denominator degree? If that's true, there's not one. There is no horizontal asymptote. Right, so those are your 3 rules for your horizontal asymptotes, and the vertical is the easy one. The vertical asymptote is whatever makes the bottom 0. Okay, let's look at one example. Okay, this one just says find the vertical and horizontal asymptotes. So let's go vertical first. Vertical, I got to figure out what are the zeros in my denominator, what makes the bottom 0. So I'm going to factor that. I'll do slide divide slide. So let's slide the 2, make it 4. Let's factor that, which would be x plus 4, x minus 1. Divide by the 2 that we slid. So I'm going to get this. I'm going to get x plus 2. And x minus 1/2 is okay. Can leave it like that for now. Because I'm looking for asymptotes, not necessarily what the exact factoring form is. Okay, so my vertical asymptotes, there are 2 of them. It's whatever makes the bottom 0. So one, and you got to put x equals with these because they are lines. Okay, so make sure you put x equals. X equals -2 is one vertical asymptote. X equals 1/2 is another vertical asymptote. Again, whatever makes your denominator 0. The horizontal asymptote, remember 3 rules. It's all about the degree. So I'm looking at the degree of the top and the bottom. They're both 2. Anytime the degrees or the biggest exponents are the same, you do the leading coefficient of the top over leading coefficient of the bottom, which in this case is a 3 and a 2. So my horizontal one, you got to put y equals because it's the horizontal line. Y equals 3/2. That's your horizontal asymptote. And again, we'll go over those rules and give you some gestures for them tomorrow. Hopefully that helps. But you got to learn those rules, okay? Because to graph these, you have to have the asymptotes on the graph. All right? That's it for today. I'll see you tomorrow. We'll work on this stuff. See you then.